Imagine a cyber attack that we as humans cannot conceive of, which means there's no defense for it because no one ever thought about it, right? These are real issues. A biological attack, you take a virus, I won't obviously go into the details, you take a virus that's bad and you make it undetectable by some changes in its structure, which again, I won't go into the details. We released a whole report at the national level on this issue. So at some point, the government, and it doesn't appear to understand this now, is going to have to say, this is very big because it affects national security, national economic strengths, and so forth.
Google's ex-CEO is warning the world that the next level of AI is approaching fast, and it's going to cause disastrous effects on humanity. His interview is sparking lots of debate on the internet, so let's watch it and I'll dissect it as we go along.
A reasonable prediction is that we're going to have specialized savants in every field within 5 years. That's pretty much in the bag as far as I'm concerned.
Sure.
And here's why. You have this amount of humans, and then you add 1 million AI scientists to do something, your slope goes like this, your rate of improvement. We should get there. The real question is, once you have all these savants, do they unify?
Mm-hmm.
Do they ultimately become a superhuman? The term we're using is superintelligence, which implies intelligence that beyond the sum of what humans can do.
Mm-hmm.
The race to superintelligence, which is incredibly important, because imagine what a superintelligence could do that we ourselves cannot imagine, right? It's so much smarter than we. And it has huge proliferation issues, competitive issues, China versus the US issues, electricity issues, so forth. We don't even have the language for the deterrence aspects and the proliferation issues of these powerful models.
Or the imagination.
Totally. You're going to have an agentic revolution where agents are connected to solve business processes, government processes, and so forth. They will be adopted most quickly in companies that have a lot of money and a lot of time latency issues at stake. It will be adopted most slowly in places like government, which do not have an incentive for innovation, and fundamentally are job programs and redistribution of income kind of programs.
Mm-hmm.
So call it what you will. The important thing is that there will be a tip of the spear in places like financial services, certain kind of biomedical things, startups, and so forth. And that's the place to watch. So all of that is going to happen. The agents are going to happen. This math thing is going to happen. The software thing is going to happen. We can debate the rate at which the biological revolution will occur, but everyone agrees that it's right after, that we're very close to these major biological understandings. In physics, you're limited by data, but you can generate it synthetically. There are groups which I'm funding, which are generating physics, essentially models that can approximate algorithms that cannot be, they're incomputable. So in other words, you have essentially a foundation model that can answer the question good enough for the purposes of doing physics without having to spend 1 million years doing the computation of, quantum chromodynamics and things like that.
Yep.
All of that's going to happen. The next questions have to do with what is the point in which this becomes a national emergency? And it goes something like this. Everything I've talked about is in the positive domain, but there's a negative domain as well. The ability for biological attacks, obviously cyber attacks. Imagine a cyber attack that we as humans cannot conceive of, which means there's no defense for it because no one ever thought about it, right? These are real issues. A biological attack, you take a virus, I won't obviously go into the details, you take a virus that's bad and you make it undetectable by some changes in its structure, which again, I won't go into the details. We released a whole report at the national level on this issue. So at some point, the government, and it doesn't appear to understand this now, is going to have to say, this is very big because it affects national security, national economic strengths, and so forth. Now, China clearly understands this, and China is putting an enormous amount of money into this. We have slowed them down by virtue of our CHIPS controls, but they've found clever ways around this. There are also proliferation issues. Many of the chips that they're not supposed to have, they seem to be able to get. And more importantly, as I mentioned, the algorithms are changing. And instead of having these expensive foundation models by themselves, you have continuous updating, which is called test time training. That continuous updating appears to be capable of being done with lesser powered chips.
So here, Eric explains why big tech companies are building more and more databases and what their goal is.
So the people who are opposed to that view, and again, we don't know, would say the following. If you take a general purpose model and you specialize it through fine tuning, it also becomes more brittle. Their view is that what you do is you just make bigger and bigger and bigger models because they're in the big model camp, right? And that's why they need gigawatts of data centers and so forth. And their argument is that that flexibility of intelligence that they are seeing will continue. Dario wrote a piece called basically about machines, and he argued that there are
machines of grace,
machines of amazing grace, I think. And he argued that there are three scaling laws playing. The first one is what you know of, which is foundation model growth. We're still on that. The second one is a test time training law. And the third one is a reinforcement learning training law. Training laws are where if you just put more hardware and more data, they just get smarter in a predictable way. We're just at the beginning, in his view, of the second and third one beginning. That's why I'm sure our audience would be frustrated. Why do we not know? We don't know, right? It's too new, it's too powerful. And at the moment, all of these businesses are incredibly highly valued. They're growing incredibly quickly. The uses of them, I mentioned earlier, going back to Google, the ability to refactor your entire workflow in a business is a very big deal. That's a lot of money to be made there for all the companies involved.
Here, Eric is talking about how AI is going to take over both jobs and businesses.
How do you think about the job market over the next 5 years?
Let's posit that in 30 or 40 years, there'll be a very different employment, robotic, human interaction.
Or the definition of do we need to work at all?
The definition of work, the definition of identity. Let's just posit that. And let's also posit that it will take 20 or 30 years for those things to work through the economy of our world. Now in California and other cities in America, you can get on a Waymo taxi. Waymo, it's 2025. The original work was done in the late 90s. Yes. The original challenge at Stanford was done, I believe, in 2004.
The Doppler Grand Challenge. It was 2004.
Right. 2004.
Sebastian threw in one.
So more than 20 years from a visible demonstration to our ability to use it in daily life. Why? It's hard, it's deep tech, it's regulated and all of that. And I think that's going to be true, especially in robots that are interacting with humans. They're going to get regulated. You're not going to be wandering around and the robot's going to decide to slap you. It just doesn't, society's not going to allow that sort of thing. It's just not, it's not going to allow it. Yeah. So in the shorter term, 5 or 10 years, I'm going to argue that this is positive for jobs in the following way.
Okay.
If you look at the history of automation and economic growth, automation starts with the lowest status and most dangerous jobs and then works up the chain. So if you think about assembly lines in cars and furnaces and all these sort of very, very dangerous jobs that our forefathers did, they don't do them anymore. They're done by robotic solutions of one another, and typically not a humanoid robot, but an arm. So the world dominated by arms that are intelligent and so forth will automate those functions. What happens to the people? Well, it turns out that the person who was working with the welder, who's now operating the arm, has a higher wage. And the company has higher profits because it's producing more widgets. Mm-hmm. So the company makes more money and the person makes more money, right, in that sense. Now, you sit there and say, well, that's not true because humans don't want to be retrained. But in the vision that we're talking about, every single person will have a computer assistant that's very intelligent that helps them perform. Mm-hmm. And you take a person of normal intelligence or knowledge and you add a sort of accelerant, they can get a higher paying job. So you sit there and you go, well, why are there more jobs? There should be less jobs. That's not how economics works. Economics expands because the opportunities expands, profits expands, wealth expands, and so forth. So there's plenty of dislocation. But in aggregate, are there more people employed or fewer? The answer is more people with higher paying jobs.
Is that true in India as well?
It will be. And you picked India because India has a positive demographic outlook, although their birth rate is now down to 2.0.
Ah, that's good.
Is it?
The rest of the world is choosing not to have children.
Mm-hmm.
If you look at Korea, it's now down to 0.7 children per 2 parents.
Yeah.
China is down to 1 child per 2 parents.
It's evaporating.
Now, what happens in those situations? They completely automate everything because it's the only way to increase national priority. So the most likely scenario, at least in the next decade, is it's a national emergency to use more AI in the workplace to give people better paying jobs and create more productivity in the United States because our birth rate has been falling. And what happens is people have talked about this for 20 years. If you have this conversation and you ignore demographics, which is negative for humans, and economic growth, which occurs naturally because of capital investment, then you miss the whole story. Now, there are plenty of people who lose their jobs, but there's an awful lot of people who have new jobs. Mm-hmm. And the typical simple example would be all those people who work in Amazon distribution centers and Amazon trucks. Those jobs didn't exist until Amazon was created, right? The number one shortage in jobs right now in America are truck drivers.
Yes.
Why? Truck driving is a lonely, hard, low-paying, right, low status of good people job. Mm-hmm. They don't want it. They want a better paying job, right? Going back to education, it's really a crime that our industry has not invented the following product. The product that I want it to build is a product that teaches every single human who wants to be taught in their language, in a gamified way, the stuff they need to know to be a great citizen in their country, right? That can all be done on phones now. It can all be learned, and you can all learn how to do it. And why do we not have that product, right? The investment in the humans of the world is the best return always. Yeah. In knowledge and capability, it's always the right answer.
So in this next part, Eric Schmidt says that this is a perfect window of opportunity for humans to act. Otherwise, they'll lose everything.
Let me try and get your opinion on this because you're so influential with... So I've got about 1,000 people in the companies where I'm the controlling shareholder. And I've been trying to tell them exactly what you just articulated, where a lot of these people have been in the company for 10, 15 years. They're incredibly capable and loyal, but they've learned a specific white-collar skill. They worked really hard to learn the skill, and the AI is coming within no more than 3 years and maybe 2 years. And the opportunity to retrain and have continuity is right now. Mm-hmm. But if they delay, which everyone seems to be just, let's wait and see. And what I'm trying to tell them is if you wait and see, you're really screwing over that employee.
So we are in wild agreement that this is going to happen. And the winners, we are the ones who act now. What's interesting is when you look at innovation history, the biggest companies who you would think of are the slowest because they have economic resources that the little companies typically don't. They tend to eventually get there, right? So watch what the big companies do. Mm-hmm. Are there CFOs and the people who measure things carefully, who are very, very intelligent? They say, I'm done with that 1,000 engineering team that doesn't do very much. I want 50 people working in this other way, and we'll do something else with the other people.
And when you say big companies, we're thinking Google, Meta. We're not thinking, big bank hasn't done anything.
I'm thinking about big banks. When I talk to CEOs, and I know a lot of them in traditional industries, what I counsel them is you already have people in the company who know what to do. You just don't know who they are. Mm-hmm. So call a review of the best ideas to apply AI in our business. And inevitably, the first ones are boring. Improve customer service, improve call centers, and so forth. But then somebody says, we could increase revenue if we built this product. I'll give you another example. There's this whole industry of people who work on regulated user interfaces of one another. I think user interfaces are largely going to go away because if you think about it, the agents speak English typically or other languages. You can talk to them. You can say what you want. The UI can be generated. So I can say, generate me a set of buttons that allows me to solve this problem, and it's generated for you. Why do I have to be stuck in what is called the WIMP interface, Windows icons, menus, and pull down, that was invented in Xerox PARC, right? 50 years ago. Why am I still stuck in that paradigm? I just want it to work.
Now, the following part, it's really important. Eric talks about the future of college education when AI is dominating everything?
Kids in high school and college now, any different recommendations for where they go?
When you spend any time in a high school, or I was at a conference yesterday where we had a drone challenge, and you watch the 15-year-olds, they're going to be fine. They're just going to be fine. It all makes sense to them, and we're in their way.
They're digital natives.
But they're more than digital natives. They get it. They understand the speed. It's natural to them. They're also, frankly, faster and smarter than we are, right? That's just how life works, I'm sorry to say. So we have wisdom, they have intelligence, they win, right? So in their case, I used to think the right answer was to go into biology. I now actually think going into the application of intelligence to whatever you're interested in is the best thing you can do as a young person.
Purpose-driven.
Yeah.
Any form of solution that you find interesting. Most kids get into it for gaming reasons or something, and they learn how to program very young. So they're quite familiar with this. I work at a particular university with undergraduates, and they're already doing different algorithms for reinforcement learning as sophomores. This shows you how fast this is happening at their level. They're going to be just fine. They're responding to the economic signals, but they're also responding to their purpose, right? So an example would be you care about climate, which I certainly do. If you're a young person, why don't you figure out a way to simplify the climate science to use simple foundation models to answer these core questions?
Yeah.
Why don't you figure out a way to use these powerful models to come up with new materials, right, that allow us, again, to address the carbon challenge? And why don't you work on energy systems to have better and more efficient energy sources that are not less carbon? You see my point.
In this following part, Eric says that we won't be able to turn off AI ever. Watch this.
It's going to be
What
torture.
is also interesting is that in my career, I used to give these speeches about the internet, which I enjoyed, where I said, the great thing about the internet is there's an off button, and you can turn off your on button, and you can actually have dinner with your family, and then you can turn it on after dinner. This is no longer possible. So the distinction between the real world and the digital world has become confusing. But none of us are offline for any significant period of time.
Yeah.
And indeed, the reward system in the world has now caused us to not even be able to fly in peace, right? Drive in peace, take a train in peace.
Starlink is everywhere.
Right. And that ubiquitous connectivity has some negative impact in terms of psychological stress, loss of emotional, physical health, and so forth. But the benefit of that productivity is without question.